Behind me is the Palazzo dei Normanni in Palermo, Sicily. This structure began as a fort in the 9th century CE while Sicily was under Islamic rule. But in the 11th century, Normans conquered Sicily, and once they gained control of Palermo, they began expanding and renovating the structure. Roger I was appointed the first Count of Sicily in 1071, followed by Simon of Sicily in 1101. He was followed by Roger II in 1105, who made Sicily, as well as his territories in Malta and southern Italy, into a full-fledged kingdom, becoming the first king of Sicily in 1130. In many ways, this was the high point of medieval Sicily. Under Roger's reign, Sicily became one of the wealthiest kingdoms in all of Europe, even wealthier than England. But despite Sicily coming under Christian rule, there's something that might surprise you inside.
This block of marble stands near the Palatine Chapel within the Palazzo. You can see that it is inscribed in 3 rows. The first is in Latin, the second in Byzantine Greek, and the third in Arabic. It dates to 1142 from the reign of Roger II and commemorates the construction of a horologium, a clock, although no further details are known.
This stone stands as a testament to the multicultural environment of Sicily in this time. And it's not alone. Roger's royal mantle bears an Arabic inscription, and there's even a quadrilingual epitaph for Anna, the mother of Grisandus, a priest at the Palatine Chapel, which includes Judeo-Arabic. Unlike many other places, the rulers of Sicily did not expel those of other faiths. Rather, Sicily became a hub of cultural exchange. And that's particularly important for the history of astronomy because Christian Europe lacked the sophisticated astronomical models that the Islamic astronomers had inherited from the Greeks and spent centuries refining. So, in today's video, we'll explore Sicily's rich history of astronomy before the telescope.
Beginning in the 8th century BCE, Greeks began colonizing Sicily, mostly in the southeast. And as the Greeks built, they aligned their buildings with the heavens. The most famous Greek site in Sicily is Agrigento's Valley of the Temples. This valley contains the remains of as many as 10 temples. The majority of Greek temples across the Mediterranean face the eastern horizon, with their front facing within the arc of the horizon that the sun can rise at throughout the year. The overwhelming majority of these temples on Sicily, not all necessarily in Agrigento, follow this pattern, with 38 of the 41 temples for which their angles have been reviewed face east. However, the sun can rise roughly 31 degrees to either side of due east on the solstices, leaving a large arc along the horizon to which temples could be aligned and still be considered facing east. So, how did the Greeks decide where precisely to point their temples? One possible explanation is that they picked the position of the sun on the date that the temple was founded. Another possibility is that it was the position of the sun for the feast day of the god to whom the temple was dedicated. However, that one is considered unlikely as the Greeks used a lunisolar calendar, which would mean that the position of the sun on the same day the following year would not necessarily be consistent. The reality at Agrigento is that some of the temples appear to simply be aligned with the adjoined Greek city, Akragas. This city has its streets laid out in a grid pattern at right angles to one another, and was likely chosen to be that way due to the topology of the hill on which it sits. The roads pointing east have an azimuth of 78 degrees and 15 minutes. Temples matching this alignment include the Temple of Jupiter and Temple El, which was directly on one of the roads from the town. However, other temples have different orientations. The temples of Concordia and Heracles are aligned due east to the position the sun rises on the equinoxes. The Temple of Juno has its front facing an azimuth of 82 degrees and 24 minutes. This is a definite break from the equinoctial alignments, and it is proposed that it is instead a stellar alignment. To analyze this, astronomers can look at the circle that this point of the horizon would trace on the celestial sphere, and then ask if it intersects any bright stars or constellations. Scholars note that the small constellation of Delphinus rose on the horizon at this point in the era that this temple was constructed. It should be noted that the attribution to Juno is traditional, but entirely unsupported by the archaeology, leaving scholars to propose that this could indicate that the temple was originally dedicated to Apollo, who was loosely associated with this constellation. And curiously, no other temple in the complex is known to be dedicated to Apollo. However, we should be skeptical of this, as the researchers admit that Apollo was more closely connected with the constellations of Lyra and Cygnus. Furthermore, they fail to mention that the bright star Altair is very close to this same declination. This is the brightest star in the constellation of Aquila, which was associated with Zeus. The temple of Demeter and Persephone also has a non-solar alignment, pointing to a position on the celestial sphere outside the range that the sun can possibly obtain at that latitude. Again, the naming of this temple is traditional and not supported by actual archaeology, so the true dedicatee of the temple is unknown. But while the alignment is outside the sun's range, it is not outside the moon's range. Thus, researchers propose that this is aligned with the northernmost point that the moon can obtain, thereby providing an association with the goddess Artemis. The sanctuary of Aesculapius also has an orientation that's almost due east, but due to topography, the rising sun could not be seen directly down its length on the equinoxes. As such, it's more likely that this was oriented based on the cardinal direction. As Greek expansion on the island continued, native tribes were pushed westwards, and since these tribes were under the protection of Carthage, with whom they did a great deal of trade, it began a series of conflicts, leading to a decline in Greek dominance. The Romans then saw this as an opportunity to invade, kicking off the Punic Wars and eventually leading to Roman rule for roughly 600 years. Beginning in the mid-5th century CE, as the Roman Empire collapsed, several other groups vied for control of Sicily, including the Vandals, Lombards, and Byzantines. Eventually, the Byzantines were largely victorious, but following an internal dispute, a commander of the Byzantine fleet was exiled to North Africa. There, he requested the help of Muslims to retake Sicily. This began a century-long attempt by the Muslims to take Sicily, which they eventually did. However, divisions would eventually form. In the 11th century, the Normans were asked to come to Sicily to assist the Emir of Catania against the Emir of Agrigento, but they quickly decided to take advantage of these political divisions to conquer the island for themselves. However, the Normans were fascinated by the unique blend of culture that had developed in Sicily, a mix of Byzantine and Arab culture. King Roger II incorporated Arabic designs into the architecture of his palace and welcomed both Muslim and Byzantine dignitaries into his court. Among the names associated with the Sicilian courts, we find Abu Asalt Umayya, an astronomer from Cairo, who served as a physician in the court of Roger I. Although he did not work exclusively in Sicily, his works were translated into Latin and Hebrew. These included an encyclopedic work on the quadrivium, the subjects of geometry, astronomy, arithmetic, and music, as well as works on astrolabes and other instruments, a work on cosmology, and a compendium on astronomy. Another was Abd el-Monim, who wrote a work on astronomical instruments. This technical proficiency makes historians believe that he may have been responsible for the construction of the horologium previously mentioned. We also find Muhammad al-Idrisi. While he was primarily known as geographer, it is important to understand that geography at this time was largely dependent on astronomy to determine terrestrial longitudes and latitudes. Al-Idrisi was commissioned by Roger to revise all geographic maps into a work that would eventually become known as the Tabula Rogeriana, Book of Roger. According to the historian Safedi, who wrote a bibliography of Roger, Al-Idrisi produced a silver globe of the world as well as an armillary sphere for Roger. Among the Greek population at this time, we find Eugenius of Palermo. Sometime around 1154, he produced a Latin translation of Ptolemy's Optics from an Arabic source. The work has long been lost in the original Greek. Eugenius's translation survives in approximately 20 copies, and it's not known how widely circulated it was, but Optics would later serve as a reference for Roger Bacon and Johannes Regiomontanus. Eugenius also translated works by Proclus, Archimedes, and Euclid. Sicily was also home to the first known Latin translation of Ptolemy's Almagest, the most influential book in astronomy for nearly 1,500 years. This translation was done around 1160 by an unknown translator from Salerno using a Greek manuscript provided to Henry Aristippus from the Byzantine Emperor Manuel I Comnenus. This unknown translator heard a rumor that Aristippus had brought this work with him to Sicily and tracked him down at Mount Etna on Sicily's east coast as Aristippus observed an eruption of Mount Etna. However, the translator admits that his skill was not great enough to immediately translate the work, so he first studied various works by Euclid as well as some by Proclus. The aforementioned Eugenius also assisted in this translation. While this translation was more accurate than the one by Gerard of Cremona, completed in Toledo in 1175 from an Arabic manuscript, the Sicilian translation saw far less circulation. Perhaps this is because Gerard's version contained commentaries which helped explain the dense text. Interestingly, Aristippus was a translator in his own right and translated portions of Aristotle's Meteorologica and Plato's Meno and Phaedo. From him, we also get a vivid description of Sicily at this time as an intellectual hub. In the dedicatory letter for his translation of Phaedo, he writes that, "In Sicily, you have the Syracusan and the Argolian libraries. There is no lack of Latin philosophy." Although not produced in Sicily, in the late 13th century, John of Sicily produced a commentary on the Toledo tables. These tables were a sort of quick reference guide for calculating the position of astronomical objects. They were founded in Ptolemaic astronomy, but stripped out the derivations, leaving only the material and instructions necessary for the calculations. Although John produced the work while in Paris, the degree of skill shown is indicative of the environment in which he was raised. And scholars traveled to Sicily as well. The Scottish mathematician and astronomer Michael Scott was lured to the Sicilian court, where he authored fresh translations of Aristotle and Islamic commentaries on it into Latin. The translations done there include De Caelo, On the Heavens, Aristotle's treatise on cosmology, which formed the philosophical basis for Ptolemaic astronomy. We can see the cosmopolitan nature of the Sicilian court in a report by the Spanish Muslim Ibn Jubayr of Granada, who became shipwrecked in Sicily. He wrote, "The king has many Muslim doctors and astrologers who he covets and takes great care of, to such an extent that when he becomes aware of a Muslim doctor or astrologer traveling through his land, he grants him such a lavish livelihood that he forgets his home." The ability to produce and attract experts led to a golden age of Sicilian astronomy. But it wouldn't last. When the Normans first conquered Sicily, the overwhelming majority of the population was still Muslim. Although the early counts and kings did not expel them, they did encourage massive immigration of Christians from Italy, France, and other regions. Within a few short generations, Christianity became the dominant religion in Sicily, and the Christians felt that the kings of Sicily gave far too much freedom to the Muslims. When tensions rose between the crown and his Christian subjects, the Christians would direct violence against the king's Muslim servants instead of the crown itself, normalizing religious violence. Although the kings tried to keep violence against Muslims in check, they frequently failed, leading to pogroms in the 1150s, 1160s, and 1190s. And it wasn't just the local Christians that were dissatisfied with the favor Muslims were being shown in Sicily. The period we've been discussing is right in the middle of the Crusades, and the popes were not at all happy about how cozy Sicily was with the Muslims so close to the heart of Christendom. Frederick attempted to appease the Pope by passing repressive laws against the Muslims, leading to a collapse of relationship between the Muslims and the crown, and sparking a series of rebellions and reprisals. Finally, in 1224, Frederick expelled the few remaining Muslims. This marked the end of Islam in Sicily. What we see in medieval Sicily is not simply conquest and control, but a vibrant fusion of cultures, languages, faiths, and knowledge. The trilingual inscription of 1142 in the Norman Palace, the translations of Greek and Arabic astronomical works, the presence of Muslim, Greek, and Latin scholars all working in one court. These are not mere footnotes. They form the core of a civilization that allowed knowledge, science, and art to cross religious and linguistic boundaries. At the same time, this golden era was fragile. The cosmopolitan environment depended on tolerant policies, political balance, and the cooperation, or at least acquiescence, of diverse groups. As the political, religious, and societal pressures increased, many of those bridges began to deteriorate. The gradual erasure of Muslim communities did not happen overnight, but marked a turning point in what could have otherwise been an even longer period of interfaith intellectual exchange in Sicily. One that continued for over a century longer in Toledo, which may be why Toledo is referenced far more frequently in the history of astronomy than Sicily. What happened in Sicily provides us more than just architectural alignments and a brief flare of astronomical exchange. It offers a lesson. It shows us that the scientific and cultural flourishing often requires political will, openness to diversity, and respect for learning across cultures. Sicily's history reminds us what can happen when that openness is fostered, and what may be lost when it is allowed to fade.